All right, y'all. Today we're going to be talking about solving absolute value inequalities, which are similar to equations, but using that inequality notation, things are just going to be a little bit different. Okay, so let's look at example 1. We want to solve 4x plus 5 absolute value is greater than 13. So just like with equations, the first thing we want to make sure is that we have that absolute value sign isolated. On number 1, we do already have that absolute value sign isolated, so we can go ahead and split this into our two separate inequalities. So just like before, I'm going to separate this into (4x plus 5 is greater than 13). And then my other inequality is going to be the exact same left side, or exact same what's inside the absolute value, but I'm going to change the right side from positive 13 to negative 13. So this should be familiar from when we were solving equations. But the other piece that's new is that with inequalities, when we split it up, we have to flip the inequality. So instead of it being greater than 13, it's instead going to be less than negative 13. Okay, once we have those two inequalities, just like with the equations, we can solve each of them out. So in this case, I would minus 5 to get 4x is greater than 8, divide by 4, and we get x is greater than 2 for our first inequality, minus 5 to get 4x is less than negative 18, divide by 4, and we get x is less than negative 9/2. Okay. Now, an additional new piece for inequalities is, if you notice, instead of getting two x values, x equals and x equals, we get two inequalities. And these inequalities tell us a range of values that make sense in our inequality, as opposed to a specific value that is going to make our inequality true. And if you ever want to check if your inequality works out, you can do some quick math to plug in. So let's see if this is true by plugging in a number that's less than 2, but greater than negative 9/2. I'm going to plug in 0 as an example. So if I plugged in 0, I would get the absolute value of 4 times 0 plus 5 is greater than 13, which would give me the absolute value of 5, which would give me 5 is greater than 13, which of course is not true, which makes sense considering it says my answer or my solution set should be x values that are greater than 2 or x values that are less than 9/2 or negative 9/2. So additionally, let's check those two to make sure they're correct. A value that's greater than 2 would be 3, so the absolute value of 4 times 3 plus 5 greater than 13. That would give me 4 times 3 is 12 plus 5 is the absolute value of 17. And of course, 17 is greater than 13. Additionally, on my other side, a value less than negative 9/2 would be negative 5. So absolute value of 4 times negative 5 plus 5 is greater than 13. That would give me negative 15, which of course would become 15, which is greater than 13. So both of these statements are true. My middle one is false, which is why my final answer would, of course, be x is greater than 2 and x is less than negative 9/2. Okay, so that's the big difference with inequalities versus equations, is inequalities have this solving aspect to them where when we get to the end, instead of getting two distinct answers, we get a set of answers. Okay, let's look at another example. So on number 2, I have absolute value of 2x minus 7 minus 3 is less than or equal to 18. Okay, in the case of this question, my absolute value is not isolated, so I want to isolate that absolute value first by moving that 3 to the other side. So plus 3 plus 3. That gives me the new equation. The absolute value of 2x minus 7 is less than or equal to 21. Now that I have my isolated absolute value, I can split it up into my two separate equations. So absolute value of 2x minus 7 is less than or equal to 21, which I forgot to drop my absolute value, so I'm going to take those away. And then same exact inside, 2x minus 7, but then flip the inequality and change the sign. So on each one individually, I can add 7, which gives me 2x is less than or equal to 28. Then divide by 2, which gives me x is less than or equal to 14. And then over on the right, add by 7 to both, which gives us 2x is greater than or equal to negative 14. Divide by 2, which gives us x is greater than or equal to negative 7. Okay. Now, additionally, I could plug in if I need to check all of these numbers, but of course, if I did my mathematics correctly, these should both check out. Okay. The other piece is while on number 1, x greater than 2 and x is less than negative 9/2, those two inequalities are going away from each other. Values greater than 2, values less than negative 9/2. On number 2, my two inequality values are going towards each other. X values less than positive 14, but greater than or equal to negative 7. So because they're going towards each other, I can rewrite it as a compound inequality, which means this can instead be negative 7 is less than or equal to x, which is less than or equal to 14. So if I have two separate inequalities that are approaching each other, I can use this slightly different approach to rewrite those inequalities. Okay, go ahead and pause the video. I want you to practice number 1, number 2, and number 3 on your own, and then you can unpause me when you're ready, and I'll go over the answers for each. All right, let's talk about each of these. So on number 1, we shifted that 5 over first. So we get the absolute value of x plus 2 is greater than or equal to 13. That splits into x plus 2 is greater than or equal to 13, and x plus 2 is less than or equal to negative 13. Moving the 2 over on both, we get x is greater than or equal to 11, and x is less than or equal to negative 15. Two inequalities that are going away from each other, so they're going to stay separate. On number 2, we have that 3 multiplied in front, so instead we divide by that 3. One note I do want to make is that, remember, our absolute values are protected, so I'm not dividing inside the absolute value. So we get the absolute value of 2x plus 1 is greater than 1. Splitting it into 2x plus 1 is greater than 1, and 2x plus 1 is less than negative 1. Then solving out, minus 1 and dividing 2, we get x is greater than 0, and x is less than negative 1. All right, on number 3 is a little tricky. This one is isolated, so we can split it up right away into 7 minus 1/2 x is less than 4, and 7 minus 1/2 x is greater than negative 4. Subtracting 7 on both sides, we get negative 1/2 x is less than negative 3, and negative 1/2 x is greater than negative 11. Okay, now that negative 1/2 x, we can divide by negative 1/2, but a reminder, dividing by a fraction is the same as multiplying by the reciprocal. So dividing by negative 1/2 is the same as multiplying by negative 2. So if I multiply both sides by negative 2, then it's going to cancel out my negative 1/2 and give me 6. And then on my other, cancel out my negative 1/2 and give me 22. But additionally, with inequalities, anytime we multiply or divide by a negative, we flip the inequality sign again. So this one actually ends up where my original equation starts as the less than but ends as my greater than sign, and my other equation starts as the greater than but ends as the less than sign. And then this time, greater than 6 but less than 22, those are two inequalities that are approaching each other. So I can rewrite it as 6 is less than x, which is less than 22. All right, y'all, that is absolute value inequalities in a nutshell. They're pretty similar to absolute value equations, just obviously those extra rules around inequality signs.